Hi everyone. Today I'm going to talk about how you would build cloud microservices for the next billion users. And the agenda, of my talk, would be as follows. I'll first start off with an introduction. Who am I? What am I doing? How did I reach here? Problem space definition. What exactly are we trying to solve here by building microservices? Um, Requirements of the problem space and ideating a solution. How do you get towards iteratively designing using agile techniques to reach a solution? And finally, some results and takeaways as an engineer. And here is a picture that I have of a typical retail store in India. As you can see here, there are a bunch of food items, perishable items, and non-perishable items that are present here. And India is dotted, like the cities and the towns of India are dotted by like millions of these stores. And these are small and medium businesses, mom and pop shops that are run by common people for common people. So um, we found an opportunity to disrupt this space, and we felt that this would then disrupt like technology and introduce technology to a billion people. So that's why the name of the talk. Let me first begin by an introduction to myself. My name is Tejas Chopra. I am a senior software engineer at Netflix, and I'll talk about my journey. So I started off with a master's degree in Carnegie Mellon University with a specialization in computer systems. From the year 2012 to 2016, I worked at Apple and Samsung, where I was working on distributed systems. In the year 2016, I started working at a startup where I was the first hire. And what this startup was doing was it was building a marketplace for FMCG. And I'll get into what that is. You can think of it as just like Amazon, but Amazon is B2C. This one is B2B, where the buyers are retail shop owners and the sellers are wholesale traders. And my goal was to build software that can enable them to do their business in a better way, thereby enriching their lives and the lives of the customers that they serve. From 2017 onwards, I started working at a startup called Datrium and then at Box, where my job was distributed file systems, storage, replication, cloud storage. And 2020 onwards, I joined Netflix. So I'm a part of the data storage platform team here at Netflix. My job is to build, architect storage infrastructure for Netflix studios and Netflix streaming platform to store and efficiently retrieve petabytes to exabyte scale data that is produced at Netflix. Coming to the problem space definition. Like I said, there's a category of goods called fast moving consumer goods. And this is an image that captures it quite well. These are packaged goods, beverages, toiletries, cosmetics, food, other perishables. And they are typically found in the US in big stores such as Macy's and Target. But in India, they are found also in a bunch of retail stores, small that are run by small and medium businesses. The market for these is around $50 billion in India. And the business model, like I said, is there are wholesale traders on the one end and the retail shop owners on the other end. And in India, there are 0.33 million of these wholesale traders and 12 million of these retail shop owners. So that's the business model that they have. Um, the problems in this domain are that there is a lot of wastage of food, and the wastage is actually 70 tons per year for perishable items. And there are several reasons why there is this wastage. Firstly, the last mile delivery is very untimely. So the last mile is between the wholesale traders and the retail shop owners, and the delivery is generally handled by the wholesale traders, the shipment. And that is very untimely, very fragmented, which results in these consumable items perishing. Um, so that's caused a lot of wastage. There is no feedback mechanism. So if a food item goes bad or is close to getting bad, there is no way for the customer to inform the store from which he or she has bought this that this food is bad, and there's no way to relay that information upstream. There is no catalog maintained. So generally the way that this domain works is they use pen and paper to just keep a track of what is the inventory in their store. So there is no technical way of managing the catalog. And finally, there are deeply entrenched relationships. um, So typically, a retail store owner has relationships with one or two, just a couple of wholesale traders, and they only deal with them. So that way, they do not have choice to explore other wholesale traders. And these are some of the reasons why there has been a lot of wastage. And we thought, let us try to use technology to disrupt this space. This is a typical wholesale retailer that, as you can see, it is pretty fragmented. Very little technology has touched this sector. So we thought, what if we could prevent this food loss or make a dent into it? Create a marketplace for FMCG, which does not exist today for small and medium enterprises in India. The buyers would be the retail shop owners, sellers would be wholesale traders. What it does is it gives buyers a choice and sellers a platform. Choice is good. You can explore offers from different sellers. You will also have the ability to provide feedback back to the uh, wholesale traders from whom you're buying this stuff. It also gives you the ability to search and seek offers. So typically, when you open up Amazon or any other app, you can search for products, look at different offers, create a cart with a bunch of stuff, and then get the amortized cost of shipment. So that's what we wanted to bring to this sector. And finally, we wanted to build empathy for customers. And I'll expand on this point a bit in the next slide. But what we wanted to do is we did not want to just take the model that worked in different sectors and just apply it blindly here. One of our learnings was that it had to be customer is at the forefront. So you need to recognize what are some of the challenges that they face and try to solve them. Um, and that is a good segue into what were some of the challenges that we saw initially. Um, First and foremost, this sector, the people that we were trying to solve the problem for, had never used a smartphone. So to explain to them what an application is, what a smartphone is, how do they like interact with an app was a challenge and something that we actually did on our own. So we provided them smartphones and we taught them how to use a smartphone, which was a very enriching experience as an engineer. They care about battery life. Generally, the retail stores work on extremely thin margins. So they want to save on as much electricity and other resources as they can. So for them, any product that consumes less battery is a win. And so they really focused on having a good battery life for whatever app they wanted to use. Um, Thirdly, generally you see a product like an iPhone or a Samsung phone, they have data written in English about the features of the product, the attributes. But a lot of our customers were not very well versed with English language. So we had to localize the product images for consumption by these people. And that was another challenge to do. The concept of a cart, the concept of order history or tracking of orders was new to them. So we had to teach them what these things are and how they work. And finally, product images. So uh, typically, we would when we look at a product page in these different apps, we read about the like what the product is, and generally we do not focus too much on the images beyond a point. But our customer base actually just focused on the image. For them, it's easier to reorder the same stuff that looked similar to what they had, and they don't go about reading what exactly are the features of the product. So product images had to be much bigger than the text that they had. So these were some of our learnings by talking to a bunch of customers, and whatever solution we built had to take into account these learnings and try to solve them for our base. That actually led to defining requirements. What exactly should our app do or platform do? The table stakes for a marketplace are product search. You should have the ability to search and browse like products. They have different images and different variants of the products. Have an order management system that gives you an ability to add items to a cart, track your orders, and look at your history. Authentication when you log into the app, whether it is OTP or some other way of authenticating a user. Offers, which are associated with bulk orders, and they are provided by sellers. So that is again a feature that you will generally see in Amazons of the world. And finally, a way for the sellers, which is the other side of the spectrum, to ingest their products and offers into our platform. So these are some things that we have to build for it to even take off. Um, and some of the initial design choices that we took were, we started with cloud because cloud was the easiest way to bootstrap any idea. It allows you to have elasticity, scalability, security, manageability is handled by them. So it's a very low barrier to entry if you want to build systems. We relied on DynamoDB. So DynamoDB is a database that is NoSQL database, and the problem domain that we were solving or trying to solve, I did not know the structure of the data there because products can have so many attributes, and the list is endless for different types of products in this domain. So I started by creating tables in DynamoDB. I used Kinesis, which is event like producer consumer model where on the one end are producers that produce events, and on the other end are consumers that consume those events. It's like Kafka, but it is managed by AWS, and it is leveraged for asynchronous updates and other async workflows. We used Redshift. Redshift is a data warehouse where you can track different like user clicks or product searches or browsing, and that data can form insights that you can build businesses on top of it, and you can provide a view into, let's say a consumer is about to buy more chocolates because it's Christmas time. So that is the kind of insights that you can get from data warehouse, and that will help our sellers to get inventory beforehand. Given that we've chosen this system and a set of requirements, we have to now start working towards a solution. The simplest way is to take a long time and to build the perfect thing, but there is no such thing as perfect, and perfect is the enemy of good, as they say sometimes. So the right way to do it is to use agile techniques and design iteratively, and seek feedback. That was my motivation because I was so new to this field. So I wanted to like see what works for customers and what doesn't. So I started off with a pilot, and the pilot was very humorously simple. It was an SMS-based solution. So I would have a Lambda that sends an SMS every day with a list of all the products, and it would be a long SMS. And we would send it to the buyers, which are retail shop owners, and they would respond by scrolling on the SMS and then saying that they wanted a particular product and how much quantity of the product they wanted. So the advantages of this approach were, it got us to bootstrap in AWS by using Lambda, DynamoDB. It got our buyers the ability to work on feature phones without requiring to buy smartphones right away. And it allowed us to scale up to 10 stores, but not beyond that. Um, so it was a solution that was a pilot just to see, if such a thing can work in this market. The backend would have sellers uploading product information in DynamoDB, and on the other hand, the Lambda would send SMSs. What was my conclusion from this? Um, First of all, Lambda works great for timed delivery of messages. Human vetting is painful, and it has to be replaced by programs. And this approach is very rigid. It has no offers, no real-time quantity updates, no searchability, browsability, and it's just scroll based. The person has to scroll to find which product they want to buy. And even with this broken sort of a solution, we could see a surge in orders, and we were doing about $500 revenue per day. So once we were fine with the pilot, we thought, let's start developing like services. And the first stage was to split the seller portal APIs from the users, the app APIs. And we did that by having a monolithic service for the seller portal, and a Lambda for the app. So whenever an order was placed by the user, a Lambda would get invoked, which would actually deal with the order. And the sellers would ingest the product information through this service into DynamoDB. And finally, the Lambda that is invoked on an order placement would interact with DynamoDB and do real-time quantity updates. So this worked very well beyond 10 customers as well, and there was no human vetting required for this. It was automated, the flow, but there were challenges even with this approach. For example, it works with single orders. There was very minimal state management, and there was no concept of a cart here. So people just had one item that they would order. Um, Also, let's say that the seller changed the image of a product. In that case, it was because we did not have any async workflows in place. It was difficult to reflect it on the consumer's app. And one learning we had was uh, AWS Lambda is extremely slow to warm up. So the orders would take multiple seconds to even be placed. It did work, but it was not the greatest of user experiences. So we went to the second part. We replaced Lambda by a monolithic service. This service had multiple database tables that it was interacting with, such as products, order management system, notification, authentication, and thus there was a lot of business logic inside this monolithic service. The framework that I used to build this is Dropwizard, and I will get into more details. Um, it did not have any browse or search capability. It was still scrolling down to find the product. And the one thing that I did introduce was a swipe based order. So the user would look at the products, enter the quantity that they wanted, and just swipe, and it would place an order on the back end. And it did result in a lot of false positives, but it was simpler experience for our customers. Also, we introduced localization, which means that we now have product images that had content not just in English but in other languages as well. Um, One thing to note is that this does not have any relationship models. Let me get into a bit more details on what I mean. Um, when you look at a Samsung phone today, you know that the brand name is Samsung or Galaxy. The manufacturer is Samsung. The product line and product verticals are very well defined. So product vertical is that it's a smartphone, and the product line it's like it's Galaxy Series 5 or something. Uh, so these are different attributes of a product, and you can search on your app today by saying, give me all products that are created by Samsung, or give me all products in the Galaxy brand. So that means that your searchability and browsability is based on these attributes, and you want a collection of products that contain these attributes. So that means that there is a need to map these relationships between products, manufacturers, brands, product verticals, etc. And that did not exist. So that is something that we had to build to enable browse and searchability. And once we realized the pitfalls of monolithic services, we went the microservice way. So what microservices do is the problems with monolithic services are that they're difficult to scale, difficult to modify and test and release. Um, One single service is dealing with multiple database tables, so there's a lot of mixing of business logic. There is no clear separation of concerns. And monolithic services generally will only scale up to a point. There will always be a need to split it into multiple microservices. And microservices, again, there is something called as a curse of too many microservices. So you must be very careful that you do not have too few or too many. Because I've seen people sometimes create small microservices, each one talking to a separate table. And what that results in is more like latency when it comes to cross-service interactions. And you'll have to make a network hop, which you can avoid if multiple similar functionalities can coexist in a single microservice. Generally, the rule of thumb is if there are two or more functionalities, such as cart and order management, that live and die together and scale together, then I try to put them in a single microservice. So we introduced microservices. That was the first step that we did. The second thing that we did is we did not end the flow at DynamoDB. We wanted to have asynchronous flows to workflows that can like update either our insights or some other metrics. So we introduced Amazon Kinesis. Amazon Kinesis is like Kafka that is managed by AWS. Any update to a DynamoDB table can be captured by Kinesis, and you can write connectors and indexers that can consume these updates. So as you can see here, we have three different indexers here. And the catalog indexer is when the seller updates a quantity or updates an offer to a product. The catalog indexer will read that data, and then it'll finally update either the S3 bucket or the DynamoDB table again to reflect that quantity on the app. A Redshift indexer is used to track all the metrics that the user has captured and put them into Redshift for building insights into the data. And the Elasticsearch indexer, so we used Elasticsearch for searching, and this indexer's job was to, whenever a new product was ingested, it'll figure out the different attributes such as manufacturer, brand, product vertical, product line, and then index it appropriately in Elasticsearch clusters so that the user can get browse and searchability. I was talking about Dropwizard. So what Dropwizard is a collection of services. It's also a framework, but it's mostly a collection of libraries like Jackson, Jetty, Jersey, and Metrics. Jetty enables an HTTP server to be embedded inside the main method. Jersey maps the REST requests to Java objects, and Jackson allows JSON serialization, deserialization. And it's very simple to use Dropwizard. It's similar to Spring Boot, and I could have used Spring Boot as well, but a quick Google search showed Dropwizard above Spring Boot, so I just started with that. And there is really no reason why we couldn't have gone that way. As you can see here, it's very simple to define the resource path, what is produced, and give query parameters, have a get method that is timed implemented. This is a very simple example of a hello world resource that we've created. And with Spring Boot, if we would have gone that path, we would have got a dependency injection that came with it. So that's just a little nugget on how we built our microservices. And I was talking about the different attributes. So I thought I'll just share a good diagram or a good picture of what these different attributes are. So this captures all the products or most of the products by Procter and Gamble, which is a manufacturer. As you can see here, these are the separate verticals, and these are product verticals like home, hair, grooming. Product line is effectively Pampers diapers would be a product line. And you can see that there are two products that are sitting in that product line. So that's an example of how there are product verticals, product lines, manufacturers associated with a product. And the problem in this particular domain is that some products may just have a manufacturer. Some of them may have a brand. Some of them may have a product vertical and a brand and a product line. So it's really not a tree anymore. It's a graph. So we wanted to model relationships that are dynamic in this world on our DynamoDB tables. And for a lot of them, it is very difficult to get this information, which is the brand, which is the product vertical. So we had to rely on a lot of customer inputs to fill those gaps there. What we wanted is the ability to search products by one of these attributes. So if you wanted to search a product by manufacturer, you would have products by manufacturer ID and brand ID, or products by product vertical. To allow building such a system, we had to have a lot of secondary indexes in these DynamoDB tables so that you can search a subset of products from this humongous list of products. And so we had to place the product vertical ID, product line ID, brand ID, all of that in the product table. Similarly, in the brand table, I had to put the manufacturer ID. And it was the job of the catalog and the Elasticsearch indexer to, whenever a product is ingested, to update these different tables and put their secondary indexes in place. So these were some of the search and browse conundrums that we had to deal with. At this point, after we dealt with all of this, the state of the app was that the buyer could do product search and browse and place objects in a cart and order. And there was an order management system as well in place where he could track the shipments, he or she could track their shipments and inventory and look at their order history. Sellers were able to ingest new products, update quantities, offers, and get invoices for all the orders that have been placed. At this point, I think I'll get into some of the key takeaways that I had from my experience building these microservices. And I'll divide them into technical learnings and product learnings. Technical learnings. DynamoDB is not the best database for relationships. So like I said that there are different relationships between products, manufacturers, and brands. They cannot really be modeled very well with DynamoDB. Instead, I should have used a graph database. A graph database allows you to model these relationships, and it is not a secondary index lookup. The lookups are really O of 1 because the relationships are a first-class citizen in a graph database. So in hindsight, I could have used an Amazon Neptune, which back in 2016 did not exist, I think, but I could have still used Neo4j, which is a graph DB backed by DynamoDB. And I relied on DynamoDB to generate these event streams for asynchronous workflows. By having Neo4j backed by DynamoDB, I can still leverage these event streams, but the advantage is it makes those indexers very simple. I do not have to now manage these secondary indexes. Uh, Secondly, I leveraged a lot of Kinesis, which is Amazon provided Kafka alternative. But Kafka is much faster than Kinesis, and it allows for faster retrieve and stores the data for longer periods of time. I think Kinesis by default is 7 days. Kafka is much more than that, and it can be configured. Back then, Kafka did not have a lot of connectors for DynamoDB or Redshift or Elasticsearch. But today, Kafka has connectors for all of them as source and destination. So it would be much easier to design things with Kafka than Kinesis. The only challenge would be to manage it because it'll be we'll have to manage the zookeeper or the clusters of Kafka. Containerization is another thing. So the way we deployed it were several EC2 instances and of these services. But if one of them went down, we had to manually check for that, and we had alerts for it. But we had to manually bring up another one, or even set up some scaling. But I think making these apps as containerized apps and using Docker and Kubernetes, it would have made our lives much simpler because I think the manageability aspect and the automation frameworks that they provide for microservices would is really useful. Um, CI/CD pipelines again are the backbone of agile development, and we could have done a better job at introducing them earlier in the development cycle. Spinnaker is one of the open source alternatives that is actually developed by Netflix. Had I known that back then, I would have used that for automated deployment on cloud, different types of cloud, and not just stick to AWS. Today, something that's picking up is the communication between microservices. So there are several ways in which you can have one microservice talk to the other microservice. It could be REST calls, it could be HTTP calls, or GraphQL, or whatever sort of interfaces you provide. But I think that things such as service mesh like Envoy or HA proxy are picking up because they allow you to build a framework for microservice to microservice interaction, embed metrics in it, and get more insights into the kind of data that flows between microservices. It also allows you to have authentication and authorization between microservices. So that would be a very nice thing to include in our architecture. So these were all the technical learnings. Then come the product learnings. So first and foremost, what we did was we allowed customers, we gave customers this notion of a cart, but we understood that customers were not able to grasp this concept of a cart. For them, placing an order by doing a swipe was much easier and a better user experience than saving it in a cart and at the end of the day trying to place an order on the cart. So the only challenge is when you place individual orders, you will incur a shipping cost for all of these. Whereas if you place a bulk order, the shipping cost gets amortized. So what we did on our end, which Amazon has been doing forever, is we would bulk up these different orders and create a virtual cart on the backend. And that resulted in around 27% savings for customers. Um, like I said, searchability and browsability to give a better user experience was one of our top priorities. And we did a lot of customer research to fill the gaps between these attributes that a product has. And per product, there were different attributes by which the customers wanted to search. For example, customers wanted to search chocolates by their brand, but they wanted to search for some other commodity, such as toiletries by the manufacturer. So having a curated list of what these different API calls should be was very critical in giving a good experience. And that increased the orders by 24% by just introducing these different product-based searching. I mentioned that we have Redshift, that is our data warehouse for capturing insights. What we saw is that by just introducing insights into the data, we increased the revenue by 34%. And that told us a lot about customer behavior. For example, when customers during the summer season, there was an increase in demand of ice creams and chocolates as well. And we saw that customers were trying to browse them beforehand. So that gave us insights that we could forward to our sellers, and they could have the inventory ready in case customers order that. Also, customers tend to order products in clusters. So, for example, rice and wheat were ordered together generally. Sugar was never ordered in monsoon season. So all of these learnings and insights were things that we learned from the data that we collected, and it was very useful in driving our revenues. And finally, coming to the results of all of this work that we did in within a span of 6 months, the number of wholesale traders on our platform, that is the sellers, increased from 1 to 7. Our retail shop owners increased from 10 to 400, and they were touching a population of around 4 million people. The insights that we capture increased from 7,000 data points per day in Redshift to 780,000 data points per day in Redshift. And our revenue increased from $200 per day to around $8,000 per day. And finally, the reason why I'm giving this talk is the efficiency improvement. So we calculated that because of our efforts, we were able to save 27% of the food wastage that would have otherwise occurred if we were not in the play. So I think that was really the biggest takeaway for me. And I I worked in bigger companies such as Apple and Samsung, and uh, the way things work there, the technology there is very different. And sometimes when you are on the infrastructure side, you're not closely like you do not see the customer directly, and you're building something to enable workflows for someone that may not be the direct customer. But this experience in the startup was made me wear several hats and gave me exposure to product, gave me exposure to customers, and that's why it was a really fruitful experience, I would say. And here are some of the takeaways uh, that I take from this experience that I have. Firstly, you must always build software for the customer and show empathy. So in my case, I realized that the customers are not very tech savvy. So you cannot directly apply things that work for a tech savvy audience to these customers. And you need to take enable them take baby steps towards the technology and build a system and a user experience that they are comfortable using. One of the very good examples of this was the localization part of it, where I realized that they were not very well versed with the languages that we had. So we had to go back and click pictures and curate the content that we show them, and that increased their experience, improved their experience. uh, More code is more bugs. That's a common adage that there is a bug every 100 lines of code. So if you want to have less bugs, write less code. The goal is to write simple code, not too complicated code, and pick and choose your battles. So if you have a small array of 5 or 10 elements, you do not need to write an extremely complicated search like algorithm. You can just simply iterate over the array, and if it's very irregular, you can iterate over the array and find an element. So that's an example of simple lucid code that can save you a long time in debugging. Pains of scale. Things work when you scale to like 10 people, but as soon as it becomes 1,000 people, things fail. And there may be so many reasons that they fail. It could be that AWS places limits on read and write throughput of the database, so things are slower because they are throttled. It could be just that your network cannot take up that much load. Uh, What's important to know is to design systems in which you fail safe, which means that you can fail when the customer is about to place an order. And you can say that, oh, I'm unable to place an order right now for you, and we'll get back to you. But you can't fail when the customer has already placed an order and not send them that order. So how do you design systems that fail, that it's okay to fail, but that fail in a good manner? Performance on smartphones. So a lot of infrastructure where these customers are, they do not have proper networking infrastructure there. So what that means is a lot of calls to the cloud may not work there. So how do you employ caching techniques on the phone to allow them to at least browse products and then How do you also batch a bunch of updates together and send one network call instead of multiple heartbeats to the server? Those are some of the things that you should always like be cognizant of when designing systems. Invest in learning about the business and the pain points and see if tech can solve some of them. As software engineers, we often tend to just go into our own like rabbit hole and try to just focus on the problem at hand. And sometimes we do not care too much about the business, and we assume that there'll be a layer above us that will take care of translating the needs of the business to tech and tell us about it. But I felt that it is also very important as an engineer to learn about the business and to see what are some of the places where technology can improve their life. One good example was that, like I said, there was no good way to track inventory for these customers. And I thought that, you know, our order history can be a very good way to for them to know what they've ordered and maybe the first steps towards tracking inventory. So I just built something on top of the order history to tell them how many things they have in their store. And that was something that was orthogonal to what we were actually trying to give them. But it really enabled them and empowered them. So it was something that was just because I wanted to learn about the pain points. Data is gold. Uh, Having insights and metrics will always keep you a step ahead of what the customer is wanting to tell you. So you can always infer their behavior from the data. And that's why investing in data during bootstrapping is often the right thing to do. Cloud costs spiral out of hand if not designed correctly. That's something that I learned and through Redshift, my experience with Redshift back in 2016, when we went from just $500 per month to $4,500 per month, just because we had so many more insights that to look at. So it's very important to design intelligently for the cloud and see what is the footprint of the data and the costs that you have in cloud. Uh, these are some of the takeaways. I hope that I have been able to communicate my learnings, and I hope that as an engineer, I have uh, been able to put a seed in your mind as to how to design systems and software that is empathetic towards the user. With that, I end my session, and you can reach me on LinkedIn, email, or Twitter. Thank you.